Have you ever wondered what makes a corn crop truly productive? If you think it's just about planting more seeds, think again. Today, we're diving into the science of grain yield in corn, how traits like ear length, ear diameter, and kernel weight all work together to determine how much harvest you actually get. Let me set the scene. Imagine you're a plant breeder in Syria, standing in the fields at Abu Garash farm, looking at rows of maize hybrids. Your goal? To boost grain, yield the total weight of corn harvested per hectare. But what traits should you focus on? This is where quantitative traits come in. Traits like 100 kernel weight and ear length are quantitative because they vary along a spectrum, like height or weight in humans. These are controlled by many genes, each with a small effect, making them tricky but rewarding to study. You might be thinking, isn't yield just the sum of its parts? Actually, some traits are tightly linked. For example, ear diameter and kernel number per row often increase together, a phenomenon known as positive correlation. But not all relationships are so simple. In this episode, I'll walk you through how researchers untangle these relationships using statistical tools so you can see why boosting one trait might have ripple effects across your entire crop. Now, let's break down two powerful analytical tools: correlation coefficients and path analysis. Correlation sounds technical, but here's an everyday analogy. Imagine you're tracking your calories and weight. If both go up together, that's a positive correlation. In corn, if 100 kernel weight rises and yield rises too, they're positively correlated. But correlation doesn't tell us if one trait causes the other. Enter path analysis, a way to map out direct and indirect effects. Think of it as a detective's board with strings connecting suspects. Path analysis quantifies how much each trait directly influences yield versus how much it acts through other traits. For example, in the Damascus University study, the 100 kernel weight had a path coefficient of 0.516 for direct impact on yield. That's like saying, this trait pulls more weight than the others. Ear diameter and ear length also contribute, but with smaller coefficients 0.381 and 0.152 respectively. Now you might be thinking, so if I just breed for heavier kernels, I'll always get more yield? Not quite. Path analysis reveals that some traits, like kernel number per row, may increase yield indirectly by boosting kernel weight first. Understanding these direct and indirect effects helps breeders make smarter choices, stacking the odds for bigger harvests by focusing on the most influential traits. Let's turn to another scientific powerhouse, regression analysis. Picture regression as a crystal ball for plant breeders. It helps us predict how changes in one trait, say kernel weight, affect overall grain yield. Regression gives us an equation, like y equals a yaum bx. Here, y is grain yield, x might be kernel weight, b is the slope, and a is the intercept. If you're lost in the math, don't worry, think of it as your car's GPS. Input a destination, kernel weight, and it tells you how much your arrival time, yield, will change. In the study, boosting 100 kernel weight led to a predicted 40% increase in grain yield. Impressive. Increasing ear diameter predicted a 26% yield bump, while longer ears added about 17%. These results aren't just numbers, they're roadmaps for breeding programs. Now, imagine a skeptical farmer asking, isn't nature unpredictable? How reliable are these predictions? Great question. Regression models are only as strong as their data. That's why the study used 2 seasons of field trials and multiple hybrids, ensuring results weren't just flukes. So, when breeders use regression, they're not guessing, they're systematically stacking the deck in favor of higher yields, using technical tools to make the invisible visible. So, how does all this statistical wizardry translate to real-world farming? Let me tell you a story from a Syrian maize field. A breeder, informed by correlation and regression results, decides to select parent lines with the heaviest kernels and widest ears for crossing. But here's the conflict. Boosting one trait can sometimes undermine another. For example, increasing kernel number per row might decrease kernel size if resources are limited, a classic biological trade-off. To resolve this, breeders use path analysis to find the optimal balance. They target traits with the highest direct impact on yield, like 100 kernel weight and ear diameter, while monitoring indirect effects to avoid unintended consequences. This is precision breeding in action. Maybe you're thinking, what's the takeaway for farmers? Here's the bottom line. Selecting for the right combination of traits, informed by correlation and regression, can substantially boost yields. The Damascus study showed that strategic selection led to up to 40% higher grain yield, a game changer for food security. In summary, by connecting field data with statistical models, researchers and breeders turn complex genetic puzzles into practical solutions, feeding more people with smarter science. Have you ever wondered what makes a corn crop truly